My name is MC Reed. I'm a sales engineer with Contrast. Today, I'm going to be showing you the Contrast solution, the Contrast demo, but focused on how we help Microsoft-centric organizations, how we integrate with the overall Microsoft strategy. And for organizations that have centralized around the Microsoft toolset, the Microsoft offering, how do we help these organizations to find vulnerabilities, find them better than anyone else, and also how to scale that usage inside of their organization. So I will be taking you through not just the integration points for Microsoft today, but I'll be giving you an overview of the Contrast solution as well. What we should see on the screen in front of us is going to be the dashboard for an application as it is represented inside of Contrast. This application happens to be webgoat.net. Of course, WebGoat is a training guide for how to spot and remediate vulnerabilities. This one happens to be written in C#.net. What we're looking at on this screen is, of course, the application itself, but also we're getting a high-level overview of the end-to-end CICD or DevOps process. So we're not a point-in-time solution. We're not going to do a scan of your code. This is a runtime technology. It's an agent-based technology. So like the APMs that are out there, agents that architecturally are running inside the application, we're an agent-based technology as well. But instead of looking for performance problems, performance issues, we're looking for bad behavior that leads directly to security vulnerabilities. So the idea, of course, is that you're going to want to run us, obviously, at QA time, the bottleneck in the process that helps us to see all of the vulnerabilities that are in a given iteration of code. But we also want to expand out from there so that rather than detecting these vulnerabilities just at QA time, we're integrating into the developer experience as well. So that's going to be in the IDE, on the desktop, or in the environment where the developer is doing their work. We also want to integrate eventually into production as well, so that we can offer additional assurance there, so that we can find vulnerabilities there in case anything has been missed, and so that we can protect your production infrastructure. So what we're seeing on this page, of course, is a high-level visual overview of where the vulnerabilities are being found. And what we want to do is we want to help shift left. So not just finding the vulnerabilities, but finding a majority of them at the beginning of the CI/CD process, rather than at the end. And of course, that's going to help to mitigate the risk. Now, it's not just about the vulnerabilities, it's about giving you a view of the overall attack surface, your overall exposure to risk. That includes the vulnerabilities themselves. It includes when we're finding the vulnerabilities, so closer to development and further away from production. It includes overall time to remediate. That means detection, fixing the vulnerability, and sending it back down this pipeline so that we can detect these things faster and get your production application fixed faster. It means doing a breakdown between the code that your organization is writing and the code that exists in the third-party libraries that you're bringing into the application. And we're going to give you an authoritative list of what libraries are being included inside of your application and what risk those individual libraries present to the organization. And it also means giving you an authoritative list of all of the routes that are going into your web application, because in order to test your application effectively, in order to know whether or not you've truly tested all paths and detected all vulnerabilities, you first need to know what web routes are going into and out of your application to begin with. Now, what I'm going to do, I'm going to go ahead and click on the vulnerabilities tab. And this is going to take us to a view of all the vulnerabilities across all those different stages that we just saw on the previous screen that have been detected inside of webgoat.net. And I'm actually going to pick on a particular vulnerability. Scrolling down real quick. Yes, this is a SQL injection. We're seeing that this route was definitely executed. We're seeing that information was passed into the application. It wasn't even necessarily an attack. So you don't need to attack the application or successfully attack the application, or even as an organization need to be able to visualize or imagine what types of attacks to test for in order for us to do the work that we need to do as long as that web route is executed. We see that that data was passed around the application because, again, architecturally, we're inside of the application. We're watching that data move through. That means we're not just looking at the web traffic, and we know precisely how the application responds to the traffic, but we're no longer dealing with a black box scenario. And we're seeing that something potentially dangerous was done with that value. In this case, we had a value passed in, it moved around the application, it was concatenated into the SQL query without being sanitized, without being protected. That means that if the attacker makes reasonable guesses about the underlying syntax of the SQL query, eventually they could exploit a SQL injection vulnerability here, even though when we ran the web route, when we saw it run, that's not actually what the user was actually trying to do. But this is definitely a vulnerability. Now, we want to move the vulnerability detection and remediation closer to the developer without slowing down the developer's precious time. We see that a lot with SaaS tools that are out there. With the SaaS tools, you're either going to do a very long and CPU intensive analysis. You're going to get a lot of things that you may need to fix right now, or that you may need to fix philosophically, but they're not the most pressing issues of the day, and it takes a long time. Or you're going to do a fast analysis on just a couple of files. And the fewer files you have, the less contacts the analysis engine has on the SaaS side of things. The more it needs to make guesses that may be correct, they may not. That's where false positives come from. That's also where false negatives come from. We didn't have all the code that we needed. It looked like nothing happened, but if we'd gone further, if we'd scanned additional files, we would have found that there was a vulnerability there. All of that goes away with Contrast, working on your .NET Framework and .NET Core applications. And we're going to do it for pennies on the dollar in terms of native execution time. So this is going to be very fast, which is why we can deliver it directly to your developers. We're explaining to the developer at the bottom of the screen, this is what this vulnerability is. Here's why it's important. What happens a lot of time is that developers aren't necessarily security experts. They might be to varying degrees, but they're not necessarily. And so we want to report this to them in a way where they don't need to be a security expert in order to understand what happened, why it's a problem, and how they need to prioritize. So we're going to explain to them right here what happened. And then we're going to give them a detailed view of precisely how we saw that data move through the application in order to have certainty that this is something that they need to fix, that this is a problem. And then we're going to explain to them, hey, here's the coding paradigm that you need to follow, that you need to practice in your code so that this isn't a problem anymore. And so we're taking a certain portion of the automatable expertise of the AppSec team, of course, not all of it, and we're giving it directly to the developers, and that offloads the AppSec team to work on the really hard stuff. And then we're going to be able to manage the vulnerabilities that are detected inside of Contrast itself. And we're going to be able to ship these things directly off to your bug tracking system, whether that's in Azure boards, I believe that's still in here. Yeah, it's a live demonstration there, or any other it happens to be. Of course, we have an integration here directly with Azure boards. We're going to be able to do the same thing, going down to my bottom window. I'm coming over to Visual Studio. So yes, we have the Contrast UI, a very powerful and detailed UI that shows you a vulnerability-centric view of what's going on. But we don't want to give you another dashboard to need to use. So in the Microsoft organization, we want to deliver this value, the vulnerabilities that we're finding, directly to where the stakeholders, as I like to call them, are doing their work. A developer is going to be a stakeholder. Managers are going to be stakeholders as well. Developers, obviously, are primarily going to be in the IDE. So here I have a copy of Visual Studio 2019 running. We support 2019, we support 2017. We also support Visual Studio Code. The developer is coded for the day. They've started to run through their unit tests. Those unit tests are detecting vulnerabilities without the human noticing any slowdown in the application. And those vulnerabilities are being reported to this plugin here in Visual Studio. So as a matter of fact, this is the same vulnerability that we were looking at a moment ago over in the Contrast Web UI. Here's what happened, same data, Mr. or Mrs. Developer. This is why this is important. This is why this is a risk, as well as a tour of how the application needed to execute, how the data journeyed through the application in order for this vulnerability to be real, but now with the context of the source code right above. And Mr. or Mrs. Developer, here's the coding paradigm that you need to follow so that this isn't a problem anymore. And we can also directly from Visual Studio or any of the other IDEs we can manage the status of this vulnerability. We can start to manage the life cycle of the vulnerability as it goes through Azure boards. One thing I neglected to mention, let me back up to the previous screen. The bug tracker integration can either be manual, as the button click just demonstrated here, where I triage either in Visual Studio or here in the web UI, and then I send this off to Azure boards. The idea being that our remediation pipeline exists in Azure boards, so let's send this vulnerability over to there. But we also have the ability to automatically integrate, so that if you trust that our false positive levels are very low, they are, because we're at runtime, we do a complete top-down path analysis, which means we're not making the educated guesses that the other technologies have. And that means that with our false positive rate being so low, as soon as we detect a problem, there's no question about whether it needs to be fixed. We can then automatically send it off to Azure boards to send it down that remediation pipeline. That's going to start to tighten the remediation time, so the amount of time that your organization is actually exposed to the vulnerability. So that integration could be manual, let's manually triage and send it off, or it can be automatic. As soon as we run the application anywhere the vulnerability is detected, the contrast engine automatically sends it off to Azure board. Now, before I go any further inside of this product, I showed you what this information looks like inside of Visual Studio. I'm actually going to go over to Azure DevOps. So this is all an integrated live demo. And so we're looking at webgoat.net as it exists inside of Azure DevOps. And those vulnerabilities have actually been sent here. Let me scroll down for just a moment, because I just took a look at this vulnerability. Here it is. We're going to click on this one. And we're looking at the same information, but now this is a part of the actual CICD engine. So whether this information came here manually because someone triaged it or automatically was sent off here, we now can go ahead as an organization, get visibility across all the stakeholders that we need, as well as links back to the contrast UI, and then we can start to manage this. As the state changes inside of contrast, that's going to be reflected over to Azure boards. As the state changes in Azure boards, that can be automatically reflected back to contrast as well. That means that as your organization does more and more, as we report more and more, you don't have more record keeping to do, because we're going to sync the state between the two. I'm going to hop back into the contrast UI real quick. Other information that we report about the vulnerability, or sorry, about the application. We are going to give you a view of all of the routes that go into and out of that application. This is really important because your dynamic technologies depend on the route being executed in order for the vulnerability to be found. And there's a reason for that. The reason is that as we execute, we're going to be able to execute very quickly. The analysis is going to be more accurate than it is any place else. All we need to do is make sure that the route is executed. So let's make sure that we detect what those routes are, so that we can make sure that we have 100% coverage across those routes. The gray from the top down represents all of the routes inside of the application that have been detected. The green represents all of the routes that we've actually seen exercised. And the red represents the routes that we found to be vulnerable. And so we're able to get a quick graphical and intuitive view of what our overall risk is in the application. And if I scroll down, here we have a list of all of those routes. The route, as well as the server that route was detected on the last time that we saw it. If I click on a particular route, we're actually going to see the web methods inside of that route. And so we're actually going to give you a map of everything that you need to test in order to ensure that you've tested all of your application. We even have the occasional customer that will use our REST API and the QA portion of the CICD to pull these routes out, automatically generate their tests, and then execute against all of that at QA time. That means that even as developers develop, add routes, remove routes, at QA time, we're going to get an up-to-date, authoritative, living and breathing list of what those routes are, so that we always achieve 100% code coverage. I'm going to go ahead and close that out a little bit. One thing I want to quickly show you is going to be the flow map. Here in this flow map, for .NET applications, the architecture inside the application tier that we see on the left side tend to be relatively simple because of the way that .NET Framework applications are architected. With some of the other languages that are out there, this portion tends to be a lot more fleshed out, a lot more complicated. If we detect that, we're actually going to show you what the application architecture is, where all the technologies that you're using, excuse me, as well as the database calls that go into which databases, and which other applications are calling into that same database. So that's another aspect of your overall attack posture. Can we trust that the DBA has done their job, that the database is appropriately locked down? Who else is calling into that database that could, if someone misses something, possibly get at our data? So this view tends to show some insights. I'm going to click on libraries real quick. We're going to get a view of all of the libraries that are inside this application, what they are, what version they are, as well as which classes inside of that library we're using, which ones we're falling into. And if there were vulnerabilities here inside of any detected route that involved a particular library, we'd show that here as well. And so the library portion is going to start to fit into the overall, the same engine where, like with vulnerabilities, we sent that off to Azure boards to be remediated. We can do the same thing with libraries that are found to be vulnerable. We can do that with policy violations around libraries that we can set so that those can be sent off to be remediated as well. So coming back into Azure boards real quick, Azure DevOps, we talked about Azure boards, but one thing I haven't touched on just yet is going to be that middle layer, the CICD. So, excuse me, clicking around a little bit. Inside the CICD, we are deploying infrastructure out there. We view that infrastructure the same, whether we're talking about bare metal, a VM, a container, whatever it happens to be. We're able to integrate into containers. As a matter of fact, this VM that you're seeing on my screen right here, we ran a Windows installer that installed the agent as a service. And so whenever anything is run inside IIS or IIS Express on this machine, it's actually automatically instrumented inside of Contrast, and that data starts to report back to the centralized server. Likewise, if we want to deploy to an application service, to an app service inside of Azure, we make it very easy to deploy to that as well. And we do that using a facility called an extension. I'm going to click right here. Now this extension is already installed, but just for the purposes of this demo, I'm going to show it here. Right now, we see the .NET Framework extension is deployed into this app service. So whenever we run through the CI/CD, we're obviously going to deploy to this app service. It's going to be instrumented and report back to the Contrast server. I'm going to click on Add real quick just to show you that we do the same thing with .NET Core. So please excuse the lag here. But if I scroll down to the C's, we're going to see that we have extensions here for both .NET Framework and .NET Core. We do the same with other technologies as well. You know, the key is that the agent's going to run pretty much the same regardless of the infrastructure that it's deployed to. What changes is how we get the agent there. In the case of an app service, we went to the native deployment mechanism, which happened to be the extension. Coming back into Azure DevOps, I'm going to come down to the pipeline itself, the pipeline that's actually powering all of this that we see here. In here, I'm going to click on not my build pipeline, but I'm going to go to my releases. And I'm going to click on this release so that we can see kind of the recipe that this release uses when it executes. Now, you know, the mileage is going to vary here. I changed this a little bit so that I could help form the demo itself. But we see we basically have a development stage, we have a QA stage, and then we're doing a couple of other demo specific things. I do want to key in on the QA stage so that we can see how that's formed. For those of you who are familiar with Azure DevOps, you're going to see that there are a number of different points or components to the overall stage. We're also going to see down at the bottom that we have an agentless job that is a Contrast widget, it's a Contrast plugin for Azure DevOps. What we're seeing on the right side here is that the agentless job is going to allow the pipeline to proceed, or it's going to stop the pipeline based on Contrast specific information. So we can essentially put SLAs in here, whatever your organization wants to call them, that say, let's query the contrast server for number of vulnerabilities, existence of critical or high vulnerabilities, vulnerabilities of specific type, vulnerabilities of a specific age, vulnerabilities that have not yet been triaged. And if there is something that does not meet our decisioning or our metrics for whether or not to proceed, then let's automatically fail the build. We're going to have an auditable track record of that in our CICD engine, and we're going to have an auditable track record of all of that inside of the contrast results as well. So that exists right here. I do want to point out also that that's relatively newer functionality. This originally existed as a gate. That gate's been turned off for the moment, but we'll see that it's actually still configured here. So if you're, we should kind of show this is kind of the older style of doing things. A lot of people like to put the contrast functionality directly in and in the QA step. If you use a gate, we're going to expose it here as well. I think the value of it being a widget here is that gates are specific to release pipelines. And this is not. That means that this could be a part of your build as well. If you happen to do some build time testing, generating new results, you could then stop or proceed the build based on contrast metrics. The last thing that I want to show, I'm going to leave here so that I don't save anything. I'm going to go to the dashboard. You know, a lot of our organizations are going to use dashboards to populate certain metrics so that they can get a high-level, quick overview of what's going on inside of Azure from an overall CI/CD perspective, including the builds that we're running, whether or not things are populating, whether they're failing. And so we're going to actually start to feed into this data as well. These are actually all the builds that we've done inside of Contrast. So you're going to be, the idea is that wherever you get your information, however you consume it, whoever your stakeholder is, we want to deliver this information where they're already doing their work and consuming their data. Now, one of the last things that I want to show you, coming back to the Contrast dashboard, I'm going to come over to the attacks section. And as a matter of fact, why don't I back up for just a moment? This is really talking about the production portion. So we've been talking up until this point about pre-prod, about detecting vulnerabilities at development time and in QA. In production, the use cases that I find are most useful with customers are twofold. One, perhaps we have a legacy application where we don't want to devote development resources to fixing those vulnerabilities, but we do want to have protection in production that goes more in depth than a dynamic analysis technology or a WAF technology, both of which are essentially static and black box. So they're outside of the party, monitoring the traffic into and out of the application, trying to intuit or make an educated guess about whether bad behavior happened. Instead of doing that, we want to leverage our agent to detect that bad behavior. The other one is going to be, I think in a lot of organizations, a lot of Microsoft organizations, even non-Microsoft, non-C# organizations, there tends to be some inherent headbutting sometimes between pre-prod and production. Development, they've already got tight timelines of trying to push out new functionality. And whenever AppSec or Ops comes along with some, fighting a fire scenario, there's some inherent resistance because they know that their timelines are going to be blown out of the water. But if you can protect your application in production with the same agent, that's going to free up or offload development and everyone on the pre-prod side of things to schedule when they fix that vulnerability in the code the right way, because they know the production application has very good, industry standard protection there. But going back to the attacks section, we are going to protect the application. I'm going to release all the filters here, and we're going to do it in one of two modes. The first mode is more of a passive mode, where in your production application, if we see that the page is vulnerable to a vulnerability, and the traffic that's coming in, the web traffic that's coming in, is about to exploit that vulnerability, then and only then are we going to raise an error. We're not going to stop the traffic from proceeding, but we are going to let everyone in the organization know about it. Development, QA, production, we're going to report it here. And then we have a more active mode. Once you trust our false positive rate, once you trust that we can maximize the uptime of your application without unnecessarily blocking web traffic that shouldn't be blocked, you can put us into an active block mode where we'll only get in the way, we'll only take the bullet and stop the web traffic if we see that the page is both weak and the web traffic is about to successfully exploit that application. Now I have two versions of WebGo.net running. One is running, you'll see here, out of visualstudio.net. So let me minimize. I'm going to go over to my other window. You'll see it's running localhost. This is running in that passive mode, which means detect the vulnerability, but don't actually stop the web traffic. So I'm going to simulate what is normal web traffic. I'm going to query the underlying database for all rows that have the letter T in it. I'm going to click on Find Employee, and we're going to see that it gives me 3 rows. I'm then going to intentionally attack the application. We're going to detect it. We're not going to stop it. And we're going to see essentially here that we got all of the rows inside of that database. Now I'm going to go ahead and show you the second portion before I refresh the page. It takes just a second for all the data to show up here. I've got another version of the application. It's actually running on that WebGo.net app service that I showed you all in Portal a couple of minutes ago. There's been no changes to the application. The agent is running inside of both instances of the application, and one agent is marked as production and the other is marked as development. That's the only difference. The development agent just has slightly different marching orders. So I'm going to click on injection attacks. I'm going to simulate, again, correct traffic, legitimate traffic against a page that has a vulnerability in it. The agent's going to let that traffic through because it's inside of the application. It knows about the vulnerability, but it also knows whether or not the traffic is exploiting that vulnerability. Then I'm going to intentionally attack the application. The agent stopped that traffic from going through. Again, there's no difference in the versions of the application. I deployed one to Azure, I deployed the other inside of Visual Studio, and they took different marching orders. But what happened this time is we saw page is weak, exploit is about to be successful, and the agent threw an exception, giving the application a chance to respond to it. And that's because, of course, if an attacker does attack our application, we don't want the attacker to know that we're onto them. So you go to your standard retail website and it'll say, something went wrong with your request, please try it again, or whatever I'm sure we've all seen a couple of times here. I'm going to come back to our dashboard, and if I did enough tap dancing, we should see that we've got some recent activity here. Okay, so I'll give that, oh no, let me get rid of my filter. Okay, so we do have some recent activity here. So I am the operations person. I'm on the operations side of things with my application that's running inside of Azure. And operations is very different from pre-prod. They want to spot these things as quickly as possible, and they want to stop the bleeding. They don't even necessarily need to understand how to fix the problem. They need to understand it enough to protect the infrastructure against the problem. So we're going to tell them, where this traffic came from, what the ultimate result of it was, and then a lot of information about what exactly was attacked, which application, what was the nature of the attack, the vector of the attack, and we're going to see here literally the information that I passed in. And then operations wants to do something about that attack. So they may want to immediately stop the bleeding by blacklisting various IPs. Maybe we've got a botnet coming out of some region of the planet, and we want to stop a whole network from attacking your application without stopping traffic from everywhere. And we want to do it for a limited amount of time. We also may want to issue a virtual patch, which is going to be very similar to going out to your WAF and updating the static signatures in the WAF. The problem with the WAF is that the WAF is outside of the party looking in. It doesn't understand what happens to the traffic once it enters the application. And so almost by nature, our static signatures have an inherent possibility of false positives. We didn't quite get it right. We've got to go back and do it again. Or we've got N number of WAFs. I've seen retailers that will have one WAF in front of each store. So every time they want to update a WAF, they've got to go update all of them and test all of them. We can essentially make a software patch here centrally at the contrast layer. We can describe the type of traffic that we don't want the application to respond to. This is essentially a software WAF that is architecturally inside of your .NET Framework, .NET Core application with the context of how that traffic moves through the application. So there's no false positive rate that is that's the result of incorrect guesses. And when we click on the Save button, perhaps we want to add some more conditions. When we click on the Save button, regardless of whether we're dealing with one instance of the application in production or a series of 300 containers that are deployed across the globe, all running instances of the application are going to receive this instruction with the click of that button. And they're all going to start to guard against, and if you want to block that particular type of web traffic that we sit here. I'm sorry, that we show here. I'm going to go ahead and click on the back button. The last thing that I want to point out, I'm going to go over to Microsoft Teams. You know, we're going to integrate into ChatOps. We're going to integrate into a number of different technologies that are normally a part of your response system or your visualization system into your application. Here for Microsoft Teams, if we want, when a vulnerability is detected in pre-prod or production, we can go ahead and let people know in ChatOps about what's going on. We can give them links right back into the contrast environment, as well as information here so they can quickly consume and see what happened. So a quick recap. Again, we're going to be addressing all different areas of your overall CICD. Let me click back on the original screen here. We're also going to be not just displaying this information here, even though it's powerful, but trying to deliver this information to where your folks are already doing their work, whether that is in the IDE at the developer phase, in the CI/CD engine, in the bug tracking engine, or in the chat ops engine. We also have integrations into things like response management engines. We're going to allow you to visualize information inside of your various SIMs that are out there. In terms of support, again, we support .NET Core, .NET Framework. One thing that I probably want to touch on, even though we're not showing it here, is going to be policies. So clicking on my webgo.net here, let's see if we can get out of there. Being able to deploy at scale is going to be really important for certain organizations. And so that means perhaps we want to enforce policies to say that whenever we deploy this application inside of our Azure infrastructure, we want to make sure that agent is automatically pulled in. And that means you can start to do it at scale. And you've got a policy that enforces that nothing ever falls to the cracks, and any of your deployed infrastructure always has our agent embedded into it. Thank you very much for your time.